Let's get started. So this lecture is about there are situations where you change your storage layout and then you might have to do runtime migration. Um, by the way, I put on Discord that this was just merged, this slide, so and it's not updated yet in the hosted version. It should be in few minutes, just in case you're not seeing the latest one. Okay. So what do we want to do in this lecture? We want to see when runtime migration is needed. We will see how to write runtime migration. And we should see how we can verify that our runtime migration will run successfully before even executing on directly on the production, right? Okay. Generally, when you update your code and you don't change any storage, just a runtime upgrade. You just update your Wasm blob, all good. But when you update some storage layout along with your runtime upgrade, what will happen after the runtime upgrade? Your code will expect the new version of those storage layout, right? Those structs or whatever. And if it tries to decode the old layout, it will probably panic. That's the fundamental idea. So let's see some cases. Let's say you had some storage value and you change the encoding from U32 to U64. Do you think you need a migration? No? But new values will try to fit U64 in U32. And actually, the old values, when it tries to decode, it will not be able to fill the buffer because it's a scale encoded, not compact scale encoded, right? Okay, let's look at another case. You had U32, you are converting into I32 or tuple of U2 U16, right? What will happen now? It will fit the buffer, but it will have very different interpretation of what it means. Right? Can you get the mic? Who's the mic?
Well, yes, it changes maybe the data uses the same amount of memory, but it changes the needed interpretation of them.
Exactly. So it changes the meaning. It will decode it. It will think it's correct, but it's totally different meaning now, right? Okay, let's look at another example. If you remember struct, how they are encoded, and now in the struct we're adding a new field, what will happen now?
Same, now the struct uses more memory, so you need a migration.
Exactly. So our encoding and decoding has changed again. We need to somehow migrate and initialize this new value with the old ones, right? Okay, this is an interesting case. What if you add another field that is not encoded, it's a unit type encoding and scale? What will happen now? No answers? So in this case, you don't need a migration. Sorry.
It doesn't have a value, so it doesn't have a value.
Exactly. You can also skip coding for scale. So you can put something on struct and you don't encode it, right? So in those cases, it's totally fine.
I have a question here.
Yes,
Yeah, do we have any problem if we change the order of the struct?
we will see it. We will see it. Oh, not here. Maybe later. We'll see that. Let's look at the enum. We have two variants. We add a third variant. Do you think we need a storage migration? You have learned all this in scale encoding. Just have to think of in the scale terms. So in this case, we don't need a migration because our first two variants are still fine. And there is no existing storage with this variant, right? So you will only start storing new variant. 0 starts with 2 in after the runtime upgrade. Is this clear? Yeah.
Yeah, sorry, but I didn't get it. Why don't you need a migration there? At the beginning, we said that that extending a. Ah, no, it's an enum.
So
Yeah.
it's
And I thought it
yeah,
was a struct.
okay. Okay, what if you change the order of enum variants? Go on. Yeah.
I guess we need to migrate the state manage first of all, to make sure we don't have any correlation things, and then migrate it.
Exactly. But you should probably never do this. Should never change the ordering.
It's a nightmare. It is a nightmare.
It's useless. It's not serving any purpose. I can't imagine why you will ever have to do this. I didn't show the struct. But tell me, what do you think? If we change the order for struct, what will happen?
If the new introduced elements, like in the beginning, for example, like changing the order of the same
Of a
problem.
struct, yeah, let me. Yeah. Here we change the order. It's A, B, we do B, A. Should we need a migration? Why? Why?
Well, I'm answering based on my experience with Ethereum, changing the order, meaning changing the bytes instead.
Yeah, but it will fit, right? U32, U32.
It will fit, but you will have a different meaning.
Exactly.
It's exactly like I'm defining variable X and Y,
Exactly.
and I change the slot. It's they look into the value in different slots.
Exactly. So decoding works, but it totally changes the meaning. Yeah. Something to remember. So enum can have 255 variants, right? And the ordering matters both in struct and enum. Ideally, even if in struct you want to add a new field, you add later, you initialize it in some way to do some. We do some runtime migration. We'll see how we do it. Okay. We saw about now values. What about if we change the key? There was foo value, now we make it bar value. Do we need a migration? Sorry?
You actually need the type of the key itself?
So the storage name, storage value name, foo value is changed to bar value. Right? This type name is changed.
I would say no.
Yeah.
The compiler.
Do you remember how frame internally stores the key and value?
Getting kind of a prefix of the palette and.
Exactly. So what we do is palette prefix, then storage prefix, right? And the storage prefix has changed. So the key has changed now. It's a foot gun if you do this. Right? Make sense?
I would say here is no needed, since the compiler takes care of the name of the variables and the types internally. Those names are just for the programmer, not the compiler.
But this is the same name that frame uses to store the keys, to create the keys.
This is if we are using frame. If you are using different thing, it depends on how they are managing the storing.
All this is in frame context.
Yeah.
The storage value and stuff are all frame thing. So this is a frame tidbit.
Yeah, but also, well, I'm not super sure. Now I remember for calls in frame, they are encoded regarding the number of the pallet and then the number of the call. So internally, the frame doesn't store those names, just an integer.
So that's first of all a different thing that also breaks some metadata, but this is about storage. And for storage, we store in our database some key, and for that key some value. Our key has changed now. For all this, everything inside this storage foo value is now will be under bar value.
Yeah, so that's what I'm saying. I'm not sure because I remember that for calls, but not for storage. But I would bet no, not required migration.
Okay, then what do you think? Any other answer?
What was the question?
So he thinks that it should be not migration.
No, it's because how frame works. Frame like kind of like just to generate the key, kind of like taking the palette name and the storage name and with some magic around them. So like frame actually rely on how you are like naming your variable.
Is this clear for others? Like, do you agree that this will be a migration? Because if you don't, then we have to go through frame storage lectures again. And this is important to know. Can people raise hands who believe that this is the migration? Ooh, I wanted to see more hands. Okay, I'll repeat it once again. Try to believe me. So when you say when you define some storage value or storage map, storage double map, the values stored inside that is stored under a key, right? And that key we derive from the palette prefix that comes from palette name that you defined in construct runtime, concatenated with the storage name. Okay? Which means if you change the key by changing this name, you need to migrate. You need to migrate all keys under foo value to bar value. Yes.
So I haven't read this part of the tutorial. If you're migrating like that, like it's just like with a database migration, would you have to have a mapping to say, well, foo is now called bar? Because if you just delete one line and put the other one,
There are
Usually-
if there's okay, yeah. In this case, there's only one key.
Yeah.
One key value, right?
Yeah.
So you say, okay, take this value from this here and put it here.
yeah, but like, okay, so this is really simple because you're just taking away one line and the other. But like when you're making changes to, like,
Yes,
I
yes,
guess this
map.
goes back to your first principles with blockchain design. Like you're not going to try and add a whole set of state or do a whole set of renames unless it's
Yeah.
absolutely necessary.
Yes.
But in the cases when you do, my question is like, how do you say, well, this is now this and this is now that? Because it's just a change in code. It's just a diff. But
Yes.
if you have multiple changes, how do you know what maps to what? So let's say you had foo bar and A and B, and you renaming foo and bar to A and B. How do you know that foo maps to A and bar maps to B when you rename? If you do both of them, or do you have to only
So
do
are you
one?
talking about a struct or are you talking
In a
about
struct,
because in
yeah.
a struct we don't there is no scale encoding for the names. It's just the first field, the second field. So if you change the names under the struct, there is no migration
Oh,
needed.
not the struct, the storage, because it's
Let
a key
me-
value pair.
Let
So
me
like-
go to the next slide. Maybe things answer. So generally, you should never do this, right? Why would you do it? Just for the name change. But if you need to do it, there is a way. Is it? No. Oh, yeah. You can use another macro to say, okay, storage prefix is still foo value, but change the type name in your code. So you don't need to do any migration. Does that answer? Yeah? Okay, we have now some idea of how, when we want to do runtime migration. Let's see how do we write one. So once we updated runtime, what we want to do is do this runtime migration before we accept any extrinsic, before we do any palette hooks, right? Actually, somebody asked on Discord either yesterday I think about this hooks. Yeah, do you guys remember? Like, so the runtime migration is the first thing in the life cycle of what gets executed in the hooks, and then on initialize, extrinsics, and something, right? So we need a hook that you saw in that picture, if you remember, that runs before anything else, before any on initialize hook, before any extrinsic. Okay. So, and how will our this hook look like? For now, you don't have to worry about what states it's implementing, but you will have a hook where you will say there is this old storage, and you translate. Translate is a function actually given to all your storage types. It takes a closure where you can convert your old data structure into the new one. So it will just iterate over everything and transform it. And you will set some weight, how much that migration will take. This is your code, right? This has one problem. We still want to have some kind of safety that a migration is not rerun, because that could lead to other corruptions. Maybe you switched from C to B and then you did it again, right? Or if you added something new, the next time you run it, it will fail to decode. So what we want to do is run this runtime migration only once. And so we need some kind of versioning of the database. The old way how we did it was somehow keep a version of the database in our storage somewhere and keep a current version in the code, right? And whenever they are out of sync, on-chain version is lower than the current version, we do some migration. When they are in sync, we skip it. Making sense? Okay. So it's clear when we need migration. How do we write migration? There will be two types of migration you will need to do. Sometimes the migration is small, like you have maybe just storage value that you want to change. Maybe you have a storage map that has very less values that you can do the whole thing in just one block. Sometimes, let's say you have to migrate millions of accounts, right? Then you cannot do it in one block. You will have to do over multiple blocks. So then we use something called multi-block migrations. This is real code. This is how your migration looks. So what we do is we create something called version migration, which takes some migration logic, which says from which version to which version we are going. I will show you how this version is also maintained. And some weight, right? So we create, and let's see what is your migration logic. And your migration logic is something that implements something called unchecked on runtime upgrade. You do the exact same thing. You have some old storage, you translate into the new. I'm showing here a very crude way of returning weight, but you could benchmark this as well. The way Alex showed you yesterday, you could benchmark a migration function as well. And you saw already we use something called version migration. Why it's called version migration? Because it automatically checks the check that I showed you before, that we compare on-chain version and the current version. It does this automatically for you. So for every pallet, you define this pallet storage version. This internally gives your pallet two things: current storage version, on-chain storage version. The current storage version comes from whatever storage version you have set. So if you are making some change, you're going to do runtime upgrade, you will bump that. On-chain will be whatever is the version after you do the runtime upgrade. So it will be the same value that is there from previous runtime upgrade. Next time you do runtime upgrade, this will be one higher. It will do the migration, bump this up, and then stop future migrations. I'll pause here maybe.
Yeah, I have
Yeah.
many questions, but if
Yeah.
you can elaborate first on this slide again, because like I feel like where this code should be, And-
Sorry?
like where this code should be in the runtime.
So you remember the struct palette, right?
Yes.
We define this here. And this attribute macro internally generates two things for you. It somehow puts an on-chain storage version in database, right? Simple key value, something, it generates some key and some value, right? And the current storage version, which is basically what you have put here live, right?
Yeah, only the current and the previous one, not the like if I'm doing like
Yeah, only what is in the code and what is in the database. And it's only in not sync for one runtime upgrade, right? Because when you make a runtime upgrade, you will bump this storage version. And the first time it runs, before it updates the on-chain storage version, this and this will be not in
this will
sync.
be called in the hook for the runtime upgrade.
I will show you. You just, okay, maybe this is a bit confusing, but you just wrote this code. You haven't until now figured out how this will be executed. So I will show you where or how you pass this so that runtime executes this. So there is just one struct, migrate v0 to v1, and we will see what we do with this later, okay? Okay, another important thing, when you write your migration, you could also, in the same, in the same unchecked on runtime upgrade, you also have this pre-upgrade and post-upgrade, which are only feature enabled when you say, compile with this try runtime feature. And what does this do? This is the off-chain code. This will not run in your production. And you can make some state checks, some invariant checks. So you can get the old storage, store it somewhere, and once the migration is run, you do some verification that things are the way you want it to be, right? So given when is your upgrade, and at the end you do some assertions. Yeah.
Like I'm not confused. I was wondering actually, like the situation where we need to handle data first, like we added like some new fields or whatever, and we need to handle it first. Like I believe like now I guess like it might be in the pre-upgrade stage, and then I can like is these like two functions, this is where I am kind of like handling or kind of do the management or the management, like some of the steps to prepare or making sure that I'm safely upgrade in terms of handling data.
So I don't know if I exactly get your question, but let me say something and maybe it makes sense to you. This is just test code, okay? The actual transformation of data all will happen on your on runtime upgrade hook, okay? This on runtime upgrade function, okay? And these are just like your tests that you can run off chain. I will show you also how you test it against a live state of your chain. And here you just do some kind of, you capture some data before migration, you do some assertions on it at the end to make sure everything is consistent, right? Feel like the slides should be now show how this migration is put. Maybe I should move on and.
Can I ask my question
yes.
before going to the step? Because like it will be a lot in this
Yes.
case. I'm just wondering if there is like if I want to handle like my data partially, like I want to handle like part of it, and maybe kind of like decode it and like fix the problem with what the new upgrade, whatever. How we can do this one, and also like I'm not sure like you you will talk about it or not, and like kind of like a the strategies of like storage migration. And the last question, this code is like will be run by the node itself, and like he will like the node will kind of like do all the heavy work, like out of it will not be included in the block. Just like I'll upgrade it.
I'll show you the whole flow. Hopefully that makes sense. But is the first question same as this? Like you're doing some translation of old into new?
Yeah, but you are like kind of translating the whole database.
Yeah, you could do less here. No. This is only this storage item. But you could do also some filter or, I mean, generally your whole storage map or everything inside it will change, right?
Yeah, it's my bad because I thought like it's just like I'm migrating
No.
the whole database.
So maybe I can show you. So what we are doing here is I'll show you also this how you keep the old structure so you can still read it for the at least first time, right? Where you're decoding and trying to transform it into separate. So you basically create this V0, V1 modules, and you keep the old storage even after you do, like, you change in the main code and you keep the old reference just so you can migrate it. Okay, I just want to show you how to stitch it all together. So you created that migration V0 to V1. In your runtime, you will create some migration tuple with all the migrations from whatever palettes you have, and you will pass it to this executive. And this will take care of running this one time on a runtime upgrade. Okay? Any doubt with the single block migration? Okay. There are times when you will have to do multi-block migration because you have huge storage to migrate. You can use something called step migration. So what you do is you implement this step migration where you maintain a cursor. So you migrate some amount of data at a time depending on how much weight it's taking. At the end of your capacity to process more steps, you keep the cursor to the next storage that you want to migrate, and you give it a unique identifier. So it's for every palette, it's like we don't have a collision of whether this migration has been done or not done. And how you define the step? The step just already has the cursor. This will be called by your executive. It has some meter. This meter, the way it is set in our relay chain is like 80% of whatever the block can have. We keep some margin of error, right? And we try to have a step that is like we want to optimize for this step to be run around one time per block, but it has this way of writing a pattern of code where so it passes some meter, and if whole thing is not consumed, it keeps looping and keeps doing the same step. But that's the overhead. So you try to keep your step a little bit bigger such that it definitely fits in the block. And if it doesn't, it will error, right? So this is the code that you write. This is provided to you. This is general pattern that we write. if it's the first time, you start from the beginning. If it's second or other time, you start from the cursor, right? You transform it, and once you return OK none from this step, the step function will stop calling. It will set it as this migration is finished. Again, the code is there in the slides. If you have to refer it later, you will probably not need this in the assignment. Okay. So we saw multi-block. The multi-block migration is set in a different way. You need a palette migrations, and inside that you set this migrations that you need to do. So it's not exactly the same as single block migration. It needs a little bit more things to orchestrate this. It also has how much weight every block it should use to migrate it. So you can, oh, I didn't put it here. Okay, sorry. But this MBM service weight is set as 80% of max block. That is what we do. You could do maybe a bit different, but yeah, 80% seems a very reasonable value. Okay. We also provide some utilities that you can use to help with your migration. If you want to remove your palette from your runtime, you can use something called remove palette. This is kind of unsafe. It just goes over a huge palette, all the storage in it, and removes it, and it could break your chain if you're not careful, if your palette has a lot of storage. You also have a way to decode an old storage item. So first time migration you're doing, you can define this old storage with your old struct type. And you can then use that old storage to translate into the new type. Yeah, I should have used this as old storage. Yeah, I feel like I'm losing you guys. Are you still here or busy with assignment? Both? Okay, I'm gonna try to finish it quickly, okay? Give me 5 minutes. I'll just introduce you to some tools that hopefully later you will use it. So let me just show you a few things we can do. I'll finish it in 5 minutes, okay? I have your attention? Thank you. Just to revise, there was a single block migration, multi-block migration. You can look over that later. 5 more minutes. We wrote our migration, but we want to test it against a live state, not just our test, because we don't have enough data in our local test, right? So you have something called try runtime. What it does, let's go fast. You have this try runtime CLI. You create your own WASM. You run some commands. It supports other things, but I will just show you this on runtime upgrade. It has this check solve, which basically is like it does some pre-run, pre-test, and post-test. And you give it a live RPC node link, right? So this, what it will do, it will copy all the data from a live chain, right? Create its own key value database and run your migration on that. So it creates a snapshot. You can actually, there are commands to create a snapshot and keep running on top of it instead of keep trying to copy it every time, right? And okay, does this make sense? So you have this try runtime. You take your WASM with the runtime upgrade. You create some way a snapshot, and you run your migration on top of it. Yes.
Is it possible to use it just for testing? Because like this is for me, is it like I'm forking or taking a copy of the node and I'm testing against it. Can I run my test against this try runtime where I'm getting actual data from the chain?
So this is your real data. So this belongs to the real.
Yeah, my question is like, if I'm not doing migration and I want to test it, I want to run it, to run my test using this data.
Yes, I will show you. So this was one. The second, and this was mostly for runtime upgrade, but there is a way if you remember the test that you write, you put some test externalities, you do some things inside it, right? That test externality is like just some key value database, right? That where you put some things. You can build your that test externalities, some kind of externalities, by fetching some RPC link again, maybe putting only some palettes, or you can, if you leave that empty, it will download all the palette data, and you can run test as you run your unit test. Basically, it's like a unit test with,
Yes, in
with
Ethereum.
production data.
Can I set from which block? Maybe
Yes,
I don't
you
want
can. Here you see default. I don't remember all the fields, but here you can say which block hash. You can create a snapshot, and it has this thing of if snapshot is not present first time, you create the snapshot and keep repeating on that, right? Okay. Last thing, I hope, maybe there's one more thing. So in your code, in your palette code, you can also have this tri-state hooks where you have some invariant checks, which you think, okay, there is this counter and it should always be equal to the count of all the map keys, right? Something like that. And you can have all these invariants, and you can use the same try runtime checks to make, like, maybe every day you have a CI which it downloads the change state and runs this try runtime checks to ensure all your invariants are still fine. So it's like an alert. If something is weird, I didn't expect this to happen, you get an alert and you can do something about it. You can debug it. Yeah. Did you want it to? Okay. Always feel like you want to ask something. Okay. Summarize. You write a migration. Ideally, benchmark properly. You test it locally. You test it against live state. You go and deploy. Okay. That's it. Thank you for giving me the 5 minutes.